Variation. Okay, in this chapter we're going to look at two concepts. One is a type of variation called direct variation. Another one is inverse variation. Now let me explain what we mean by variation. Let's say you're moving from Lagos. You're moving from Lagos down to Abuja. If you want to get to Lagos, if you want to get to Abuja in 8 hours, that means you need to travel, let's say, at 50 kilometers per hour. If you want to get to Abuja in 5 hours, you need to travel faster. Let's say this time around at 100 kilometers per hour. If you want to get to Abuja in 2 hours, you need to travel faster, let's say at 120 kilometers per hour. Now what it means that the time it will take you to go from Lagos to Abuja varies with your speed. The faster you go, the shorter the time. Okay? So if you go faster, as you increase your speed, as you go faster, the time it takes decreases. So we can say that the time varies with the speed. Now, the type of variation, like I just said, it varies with speed. We don't know if it's direct variation or inverse variation. Now, that's what we're going to look at. If you say a factor x varies directly with another factor y, okay, how do we express it mathematically? So this is how we write x varies directly with y. So the x, to replace this variation sign with an equal to, we put an equal to and also a constant which is called k. So x equals k and we have a y. Okay, so what it means is that anytime you increase x, y will also increase, provided that this your k remains constant. So this our k is called a constant, which you don't know the value. So anytime you increase x, y increases. Now you say another factor that varies indirectly or is inversely proportional to another factor. These are right. Let's say x varies indirectly with another constant y. So these are write it. Okay. So the same thing goes x equals k, our constant, all over y. What this means, especially for those in physics, anytime you increase x, y will reduce. Okay, just like when we said that speed equals distance over time. So the distance from Lagos to Abuja is constant, it doesn't change. So distance is a constant k. If you increase your speed, the time reduces. If you reduce the speed, the time increases. So that means you can say that speed varies, is inversely proportional to your time. Okay, having understood that, if you don't understand, please kindly rewind and go to the concept again. So having understood that, we'll take some examples to see how this is applied mathematically. Okay, so now let's take the first example. It says if y varies directly as x and y equals 8 when x equals 3, what is the relationship between y and x? Find y when x equals 18. Okay, so it says the y varies directly as x. So write it, express it mathematically. Y varies directly as x means that y equals kx. K is our constant. And now says that when y equals 8, x equals 3. So what is our k? k will now be equal to 8 over 3. So what is the relationship between y and x? This is the relationship between y and x. This is the relationship. This. So find y when x equals 18. So we now know our k to be 8 over 3. And we're now told that x is 18. So y will now be 8 over 3 times 18. So 3 into 18 will give us 6. And therefore y will be 8 times 6, which is 48. So it's as simple as that. Let's take another example from inverse proportion. So the example here says R is inversely proportional to Z. Given R equals 6 when Z equals 2. Find the equation connecting X and Y. Then find R when Z equals 3. So R is inversely proportional to Z. So let's express it. R is inversely proportional to Z. So that means R equals K over Z. Given R is 6 when Z equals 2. So that means our K will be 6 times 2. Therefore K equals 12. Okay, so our formula now will be like this. R equals K is 12 over Z. So this is our formula. This is the formula connecting R and, or equation connecting R and Z. Now say it's find R when Z equals 3. So if Z equals 3, using this expression, we'll have that R will now be 12 over 3. Therefore R equals 4. So that's the solution to that. Then we'll now have another concept called joint variation. Joint variation is still the same thing, but this time around we'll have inverse proportion and direct proportion in the same equation. Okay, so this you can find it if you're studying chemistry. You have it in Boyle's law and Charles' law. So the volume of a gas of given mass varies directly as the temperature and inversely as the pressure. Write down a formula for the volume. Okay, so the volume V of a gas of a given mass varies directly as the temperature, okay, and inversely as the pressure. So if we put an equal to have that V equals T K, K is our constant, all over P. So this is our formula here. Okay, so we now find an equation that connects all if T equals 80 degrees, P equals 20, and V equals 40. So to make K subject of formula, we'll have it at 40 times 20, 1 will cross multiply, equal to 80K. So 80K equals 40 times 20, therefore K equals 40 times 20 all over 80. 0 cancels 0. 2 into 8, we'll have that as 4. 4 into 40 will give us 10. Therefore K equals 10. Now if we come back to this expression, we'll have it that V now will be equal to 10T all over P. Okay, so that is the equation that connects all of them. Now at this point, I want you to click on Start Quiz and answer all the questions